Next speaker is Julie, who is going to take us to a different perspective, a perspective more about career path than just science. And this is something very important for EERIE, I think, as we have so many young scientists here. So you had your PhD in physical oceanography and then spent a long time of your career as a professor. And now you are going to tell us you are doing something different, right?
I'll reveal it all in the remaining few minutes. Thanks, everyone. Can everyone hear me in the back? Great. Well, thanks to Thomas and Pierluigi and the others who welcomed me to share some reflections on alternate career paths. And I'm going to use mine as an example because I came from the ARC prediction community. It's sort of dazzling what's happening behind me. Shall we try again? But actually some of my early influences on my career were my time at the Santa Fe Institute working with an evolutionary biologist who was the inspiration for Jeff Goldblum's character in Jurassic Park. Do you remember the guy with the crazy hair? Life will find a way. And it was the early days of the Santa Fe Institute, this nonlinear dynamics, complex systems think tank. And we were all applying the early versions of neural networks to different problems, from economics to biology to fluid dynamics, which became my passion. I went on to do a master's in applied math and nonlinear dynamics, and then crossed paths with Steve Schneider when I was at Stanford. And he really encouraged me to think beyond the small time and space scales that I was focused on in weather and ocean prediction to think about broader time and space scales. He famously, had us all focus quite early on what crossing climate thresholds might mean. But going back, I started my career as an oceanographer with the Navy, and I found myself staring at maps of the South Pacific, as one does when one works for the Navy. And what I noticed was this pattern of warm core eddies to the north and cold core eddies to the south, just off the coast of the Philippines in the West Philippine Sea. And it looked so tantalizingly predictable that I went on a process of discovery. And I'm about to tell you if I can go to the next slide. There. What I discovered was that the origin of these eddies was monsoon wind surges or intensifications that every couple months in the winter time would emanate from Asia and create intense winds that would filter through the volcanic terrain of the Philippines, leading to alternating bands of alternately signed wind stress curl in the Philippines that would then spin up a pair of counter-rotating eddies that you see here in our simulations of 1 to 3 kilometer resolution coupled simulations. And then these eddies would detach, and this is the process is wind stress curl induced Ekman pumping that would then spin up them eddies, and then they would propagate into the West Philippine Sea. And we can see them by satellite. You can see the cyclonic eddy here with the biological signature and the anticyclone to the north. And so that field of eddies that's out in the West Philippine Sea is predictable on a certain level, and it arises from this pattern of winds filtering through the volcanic Philippine terrain. Go to the next slide.
We have a problem. That's not me doing something. We have a problem with the share. We're sharing.
Oh, okay.
People who attend remotely do not see the slides.
Oh, okay. What do you want to do about it?
We're working on it.
Okay. So let me just sort of talk through the next slides and then we'll. Oh no, here we have it. So it turns out these eddies more recently have been identified as creating also a signature, not just in the biology, but in terms of the CO2 flux. And really, to drive home what you all are all here for is that those smaller scale patterns are not at all represented in how we think about and how we, on our observations of the air sea fluxes of CO2 on a global level. I'm going to go to the next slide. Thank you. One of the other experiences that helped shape me was when I went on to be a professor working on air-sea interaction and building field campaigns and also improving our representation of these processes in coupled models. I had a joint appointment with our Department of Energy in the US that runs the atmospheric radiation measurement program. So I joined field campaigns where we were looking at aerosol cloud interactions. And we have a site based out of the North Atlantic. And just the importance of how the aerosol processes drive so much in clouds and their formation, particularly sources of biogenic origin off the ocean for aerosols, is something that I think is going to be increasingly going forward and had a big impact on me. The next slide, you already saw the preview, so I'll just start talking about it. I was on sabbatical in the Philippines as a Fulbright visiting professor, and this experience really changed me. I was teaching tropical meteorology to those graduate students that you saw in that picture that will be back in a minute. And I was building a field site in that beautiful river area that drains the mountains in the north of the Philippines into this broad coastal plain. And I was working on air-sea hydrology coupled modeling and building a larger field campaign that would be local countries. The US we had NOAA, NASA, Department of Energy, and then other countries as well were surging observational assets, ships, and aircraft into the air. But what kept on happening is that field site in the Philippines, I'm trying to get to the next slide, if you all can advance it for me, kept on getting wiped away by increasingly intense super typhoons. And I came to understand how exposed the Philippines is to climate impacts. In fact, it's ranked at the top of climate impacts, and it's not just the typhoons and the heat waves. I would include among climate impacts is the impact it's having on the youth. You can see on the chart on the right a recent survey placed of the Philippine youth. Almost 50% of them are extremely worried about climate change. Almost 75% say it has an impact on their functioning. During my time in the Philippines, almost every weekend I would dive the coral reefs in the heart of the Coral Triangle in the Philippines with colleagues at the University of the Philippines who were restoring some of the coral reefs, and came to learn just how dependent we are and other species are on the coral and how much we've lost already and what we stand to lose going forward. This was a big shift for me. I came back, I left academia, and I joined with a team to build a startup. I led early product development focused on climate risk to help people and businesses and entities understand the impacts that were unfolding. We were a pioneer in quantifying climate risk, one of the first startups in this space, Jupiter Intelligence, backed by venture capital. We were downscaling CMET projections to create parametrics for flooding, drought, heat waves, et cetera, using cloud computing. And now, at the time, Jupiter was one of the first 5 years ago, and now there's just a whole slew of companies that have sprung up to satisfy on the left, the climate analytics space. And some of them quite specialized within agriculture or financial services, among others. There's also the complementary side of the space, which is the emissions management, helping companies understand the emissions that they're producing. And for me, what this experience in the startup space represented was a way to make a difference in the flywheel of climate action, because helping businesses understand their climate risk means they're in a better position to make disclosures, like through the task force on climate-related financial disclosures, which also encourages them to disclose more fully their emissions, so they can make better commitments to net zero, even more granular targets around the science-based target initiatives. And now there's a new framework on nature-related financial disclosures, which will help entities and governments make their commitments around the 30 by 30 or protecting 30% of land and water by 2030. So the ambition is getting raised, but at the same time, we're in a really difficult spot. And the global stock take from a few weeks ago revealed that we're on track for a 2.6 degrees C world. And that's quite honestly devastating. So my big shift was to leave the climate risk space. And about a year ago, I came together with a small team to help develop more climate solutions. I noticed that venture spending, and I was a limited partner in some of these funds in the climate tech space, has been accelerating. So all of these companies that are helping with the energy transition and to help make our society more resilient to climate change. But there was a dearth of entities focused on ocean climate solutions. I came together with the team to form a venture fund focused exactly on ocean climate solutions. We have a founding partnership with Woods Hole Oceanographic Institution, and I'm building partnerships with other ocean science institutions, because the motivation is really how central the oceans are to our climate, nexus really of all the important aspects of our climate. And those near-term shifts in our climate system are all localized in our oceans. That's coral loss, ice loss, and circulation shifts. And they really are amplifying each other and fuel each other. And from a complex systems perspective, maybe it's not thresholds that are inducing these changes, but maybe the rate of change, the rate of ice loss is really contributing to the situation that we find ourselves in. So why the oceans and why would action matter here? It's because the oceans hold at least 20%, by some estimates up to 35% of needed annual emissions reductions in all of these areas you would probably anticipate. But also the oceans have the potential to contribute to the negative emissions that the IPCC report says implies that we'll be needing to do annual removals of gigatons of CO2 a year, starting as soon as 2030. And these are big markets. If you look at waste management, from the waste management perspective, the removal of carbon dioxide is a huge market opportunity. And that's why you're seeing more venture and startups coming into this space. There's promising technologies, but lots to do. This is just the ocean CDR side of it, and I'm almost done. To evaluate these technologies, the research development and demonstration part, and to see if these technologies can be scaled and are safe and effective, and move them up the technology readiness level. And maybe some of them can't be. And then we should just know that and move on and focus on the technologies that can most help us in the situation that we find ourselves. Thank you for your attention, and look forward to being with you over the next couple of days. Thank you.
Questions for Julie? I have one actually about the capture of CO2. I mean, aren't you a bit skeptical of trying to capture using a biological pump or artificial fertilization?
I am, and I feel like the best way to answer those questions is to go and do the work, and to do it in a transparent way that involves the science community at its heart in understanding what those risks may be relative to the climate risks that we face. Thank you for the question.
Other question?
Yeah. Did you follow the loss and damage discussion? Do you know if that, how that affects the sort of, I don't know, the private sector? Does it affect it at all? Right now, there apparently is this agreement on loss and damages, whether that gets that's signed or not. Like, is the private sector involved in assessing loss and damages? I always just wonder on the whole loss and damage discussion of sort of climate policy.
Yeah, I would imagine that would unfold on the attribution side.
Yeah.
With attribution, but at a certain point, there will be.
You know, like your coral reef example here, I guess would be a claim for loss and
On the
damages.
legal side of it, the documentation and the evidence.
Yeah.
It seems like it could vary long.
We don't get to go yet.
It's best, I think, if you stay in front of the microphone for the people who are online.
I'm ready.
My question is about timescales of interest to the different sectors. So I did work a little bit in climate risk, and the typical person we were interacting with only cared about next year, maximum 5 years. Now that you're going to these climate solutions, what kind of timescales do people have in mind when you talk to them?
Right. So, from a regulatory perspective, some of those industries, like shipping, are motivated to decarbonize. So their timescales get moved up, particularly when there's regulatory pressure. For the companies that are, for instance, made net zero commitments, they also aren't just stopping at by 2050, they're doing the science-based targets initiatives, a growing number of them, so that they're making specific commitments by 2030, by 2020. So I would say overall, I think the time horizons are moving up. Some of the transformations that need to happen, like at our company, I got our first utility customer, which was Con Ed, the US New York utility company. And the use case that the only use case at the time that they were most interested in was how to make their grid more resilient and spend their money at the 30 years. Like, what does their grid need to look like in 30 years? What I've seen over time is that a lot of these other industries have come in and said, how do we make ourselves more resilient in the next 5 years? And I think that's been a big shift in the climate risk space. And on the climate solutions side, the other aspect of some of those changes that I mentioned is on the CDR side, there's growing interest in how do we do larger scale removal safely, both at land and potentially in the air and the sea. And there's a whole suite of options from the nature base to direct air capture to what opportunities might be in the ocean to do in a safe way. And that's on the near time horizon. Those technology the research and the pilot studies are being conceived now.
Yeah, so I turn perhaps to Thomas. Can we take
one more?
We can take one more question. So
okay,
you are on.
Thank you, Julie. Talking of risk, but I'm actually very interested in understanding the risk behavior of investors, particularly when it comes to marine CDR, because it's highly unusual that you get so much money flowing into such early stages of development of new technologies. And also, I mean, talking about just the regulatory aspect of it, at the moment, you wouldn't get any CO2 credit if you took it out from the ocean. So just this as one of the examples. Where do you see the primary driving force at the moment, and how vulnerable is it to various aspects, such as, for example, the crisis we have at the moment in the forestry sector because of the Kariba project being killed and so forth? So how do you judge the situation right now?
So there's a lot to be learned from the terrestrial-based carbon markets, and a lot of people who are thinking about how to build platforms, particularly around monitoring, reporting, and verification, which is a whole nother area here that underpins all of this, are really wanting to use best practices on how the ocean carbon markets could unfold if they come into being. In the US, our Office of Science and Technology Policy has developed an internal task force to give guidance in the next year on that regulatory question that you asked. So at least from the US, if not other countries, I think we're going to start seeing more guidance associated and with it. And these are voluntary carbon markets. So what people are willing to to pay for, right? So we have advanced market commitments. Frontier Fund is $1 billion fund that's led by Stripe and other companies that have put in money in order to help the companies and scientists in research positions work together with the companies to get to a demonstration project if warranted. So to be able to take on that, the capital risk, so to speak. And those entities like Frontier Fund, Advanced Market Commitments, a growing part of their portfolio is ocean-based. It's about 30% ocean-based now, but some of it is direct air capture. A lot of it is direct air capture. These are very expensive credits. You know, they're paying like $1,000 a ton for it. In the not too distant future, the supply will be limited. There won't be enough supply of them. Does that help? Yeah. Thanks.
Thank you very much.